Hello everyone, it's Miss Matt, and today we're going to be working on other bases that we've seen or that we haven't seen using the dot and box method. So if we remember, the dot and box method is as shown. And we'll do binary. So we'll do 2 to 1 dots. And let's add another square just in case. So let's say that our number is 7. We have 7 dots. And we need to find out what the number is in the binary code. So let's pick up another color so we can do some exploding. So we know that 2 dots can move over and explode into 1 dot. And we'll keep doing this for other groups of 2 that we find. So we found 1, 2, 3 groups, and we have 1, 2, 3 dots here, and there's 1 left over here. So the last number of the code is 1. Are there any groups of 2 here? Yes. Let's pick another color, just so we can see what we're doing. Let's pick another group of 2, and there's only 1 group of 2 here. And let's move it over and place it as 1 dot over here. So there's 1 dot here and 1 dot here, which gives us 111 as our code for 7 in binary. So that's just a little bit of review. Okay everyone, let's try another base. We're going to try base 5. So we're going to pick a number first. Let's pick 14. So let's get 14 pom-poms out on the floor here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And now let's double check to make sure we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Great. So with the base 5 system, we need every number 1. This is the ones place, so everything is going to be 1 here, worth 1. But here, everything will be worth 5. So we need to take groups of 5 and move them to this box, but explode them into 1. So let's start. Here is 1 group of 5. Here is a second group of 5. And here is, oh, it doesn't quite reach 5. But let's explode both of these. Into 2. All right, so we don't have any more groups of 5 to move to the next. So our code for the number 14 in base 5 is 2, 4. All right, so using base 5 again, we are starting with the number or the code 152 base 5. So let's find out what number that will come out to in our usual base 10 system. So we have 1 here, and when we move it to here, it becomes 5. So 1 becomes 5. And let's explode that into 5. And now how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So each of these is going to explode into 5. Now, that's a big number and it will be a lot of pom-poms, but we're going to figure this out, okay? So here's 1. One, 2, 3, 4, 5. Let's move these to the bottom. 1. 1, 2, 3, 4, 5. 1 again. 1, 2, 3, 4, 5. Okay. 1 again. 5. 1 turns into 5. Oh, 1 turns into 5. 1 turns into 5. 1 turning into 5 yet again, and 1 more that turns into 5. All right, so let's count these up. We can count up by 5s because we have different colors, and then we'll add the 2 onto the end. So let's count 5, 10, 15, 20, 25, 30, 35, 40, 45, 46, 47. So we found out that the code 142 in base 5 is equivalent to 47 pom-poms, or the number 47, but also 47 pom-poms. All right, everyone, as a last note, let's talk about base 5 and what numbers represent each box. And we're just going to use these 3 boxes, okay? So in the first box is represented by the number 1. And that's because this is the ones place, and each one turns into, each one over here will turn into 5, which will each in turn turn into 5. And so they will just be worth 1 each. So if we have 5 here, it will turn into 1, which means this place is worth 1, 2, 3, 4, 5. All right, so we know that if we collected all of these and put them over here, they'll explode into 1. But it's worth 5 for each of these pom-poms, all right? So that means we have to explode bigger, which means that we're going to have 5 times. So let's represent that with pom-poms. Here is 1 5. Here's 2 5s. Here is 3 5s. 4 5s. And 5 5s. And 5 5s is how many? Let's count. 5, 10, 15, 20, 25. So this third column over here represents 25. This second column represents 5. And this first column represents 1. Remember, when we move them over, they'll explode into even more. But actually, what I meant to say is that these this is just a representation of how much one pom-pom is worth in each of these boxes. So this would be a very big number if we had 25 pom-poms here and we exploded them all the way to here. And I don't have enough pom-poms to show you guys, but I assure you it is a huge number. So yeah,